So in class, we did a lot of practice with changing Cartesian coordinates into polar coordinates, and here they would like us to change a Cartesian equation into a polar equation. Remember that polar graph equations are written where the radius is a function of theta, so r is a function of theta. We still have at our disposal all of the formulas that we had before, so r is equal to the square root of x squared plus y squared. That just comes from the right triangle Pythagorean theorem. And we have that the tangent of theta is equal to y over x. Notice we write this as the open equation, tangent of theta equals y over x, so that you can solve for all possible solutions of theta and find the appropriate theta based on which quadrant you're in, as opposed to writing it as the inverse tangent function, which implies our answer has to be in quadrants 1 or 4. So before we start this with the formulas, let's try and look at it from a more conceptual standpoint. We know that x squared plus y squared equals 3 in Cartesian coordinates is simply a circle with the center at the origin, whose radius should be the square root of 3. That comes from information we already know from algebra. Based on what we did in class, if I'm graphing in polar and I want all the points on a circle with radius 3, a good guess would be that this equation should be r equals the square root of 3, right? This would be the function, that's the constant function in polar, like the example we had done with y equals 1 versus r equals 1. If the radius stays constant at radical 3, that would give me a circle of radical 3, which is what I want. Let's see how it looks like when I plug in the formulas. So I notice here I need to replace x and y to be either r or theta. So I look at my formulas. If I start trying to replace x and y with tangent, I'm going to get all kinds of horrible trig formulas that look like x times tangent of y squared, and I'm still going to have x's and y's, and I'm only introducing tangent of theta. So if I focus here, I notice that r is the square root of exactly what I have there. So by squaring both sides, it should be a fairly simple algebraic manipulation here. So what it would look like is we have x squared plus y squared equals 3. So I'm going to take the square root of both sides. So I get the square root of x squared plus y squared equals 3. And now I'm just going to substitute the square root of x squared plus y squared is r. So we get r equals the square root of 3 for our final equation in polar, which gives me the same graph, right? I want an equation in polar coordinates that will also give me a circle of radius radical 3, center 0, 0. Again, based on our experience with polar graphs, that would have been our guess as well, even without doing all the calculations which now verify that.